So dear students, welcome to the session. So today we are going to discuss about thermal properties of matter. And as you all know, it's a part of class 11 curriculum, and it's very, it contains a lot of things such as heat transfer, calorimetry. Okay, so now let's start. So hello Meghna, hello Aditya, hello Varsha, hello Gurpreet. Good evening. Hello Halima, hello Shahroz. Welcome to the session. So, hello Shagun. So, student, the first question is, hello Shabnam, hello Raju. So, everyone, welcome. So, now let's see the first question. If the radius of a star is capital R and it acts as a black body, what would be the temperature of the star in which the rate of energy produced is capital Q? So, in this question, we are given that a star is there and its radius is capital R, and the star is behaving as a black body. Okay. So, which law will apply here? Will apply Stephen-Boltzmann law. Okay. What does that law says? It says that that the power, okay, the power radiated by a black body is given by sigma A T raised to the power of 4, where sigma is the Boltzmann constant and A is the area of A is the surface area, and T is the temperature of the body, right? This is the power radiated. Okay, the power radiated by a black body. So now, see, if the radius of the star is capital R, so what do you think? If we are taking the star as a sphere, what do you think is the surface area? It should be equal to 4 pi r square, right? 4 pi r square is the surface area. Okay, this is the surface area. So according to this law, now see what is given here in the question? The rate of energy production. Rate means its power. Okay. Okay. You want me to use the black ink, so I'll use that. Okay, no problem. Now see that power is equal to sigma A T raised to the power of 4. So this implies T is equal to P. So in this question, P is given as capital Q, right? So we can write for this question as, we can write the values as Q is equal to sigma, and A is 4 pi r square, and T raised to the power of 4. Okay. So from here, what I can say that T raised to the power of 4 is Q by 4 pi, sigma into 4 pi r square. So simply you can find that T is equal to Q by sigma into 4 pi r square raised to the power of 1 by 4. So simply we can say D is the correct answer, right? So this is a very important concept from the point of view for your NEET exam. You see, so many questions have appeared from this concept. Let's see the other question. The other question is, the power radiated by a black body is capital P, and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at the wavelength 3 by 4 lambda naught, the power radiated by it becomes Np. Okay. So the value of N is, Nilesh, every chapter is important. Every chapter has its own importance. Okay, you cannot deny any chapter's importance. So the question says that what we have to find the value of n. So students will apply two concepts here. One is Wien's displacement law, and the second one is Stephen's Boltzmann law. So using these two laws, we'll find the answer. Okay. So let us see. The question says the power radiated by a black body is P, and it radiates its maximum energy at wavelength lambda naught. So what is Wien's displacement law? It says that lambda naught multiplied by T is constant, where lambda naught is the wavelength corresponding to which there is maximum energy. Okay. So lambda naught into T is constant value. Okay. So lambda, now let's say initial temperature is T1. Okay, initial temperature is T1. So now let us say after a while, when it radiates the wavelength 3/4 lambda naught, temperature becomes T2. So we say 3/4 lambda, or you can just say that lambda naught into T1 is equal to 3/4 into lambda naught into T2. So from here, we can find the value of T2. Okay. So simply we can say that T2 is equal to 4/3 into T1. So let's say this is equation number 1. So now, as you have learned that the power radiated is directly proportional to T raised to power of 4. Okay. So initially the power was P. Okay. So we can do one thing. We can just take the ratios of the two powers. Okay. So it's given that P is the power initially. So P is proportional to T1 raised to the power of 4. And P, NP, that's the final power. So that's proportional to T2 raised to the power of 4. So what we can write? We can write P by NP is equal to T1 raised to the power of 4. T1 raised to the power of 4 divided by T2 raised to the power of 4. So we can put the value of T2 here. We get T1 raised to the power of 4 divided by 4/3 raised to the power of 4 into T1 raised to the power of 4. So from here we can cancel out T1 and T1 raised to the power of 4. So P and P also gets cancelled out. So we can simply say 1/n is equal to 3/4 raised to the power of 4. Okay. So simply n becomes how much? 4/3 raised to the power of 4. So that becomes 256/81. So this implies D is the correct answer. Okay. D is the correct answer. We have to find the value of n. So I hope you're able to understand this question. Now let's move forward. Again, this question also, see, last question was from NEET 2018 and this question was from 2017. So you can see the frequency of questions coming from the same concept in consecutive years. So a spherical black body with a radius 12 centimeter radiates 450 watt power at 500 kelvins. If the radius were halved and the temperature were doubled, the power radiated would be. So what is given in this question? In this question, it's given that there's a spherical black body. So by spherical black body, you can understand area of surface area will be A is equal to 4 pi r square. Okay. So what is power? Power is equal to sigma A T raised to the power of 4. The power radiated by a black body is given as sigma A T raised to the power of 4. Okay. So now initially A is how much? A is equal to pi into, let's say R is equal to 12. Okay, let's say R is equal to 12. We can say 12 centimeter. So we can say that area of cross section, sorry, the surface area is equal to 4 pi into capital R square. So initially we can say P1 is equal to sigma and 4 pi R square into T raised to power 4. So let's say T1 is equal to 500 kelvins. Okay, let's say T is equal to 500 kelvins. We can simply write this as, okay. Now next thing is we have to find the power radiated in the next case when the radius is halved and the temperature is doubled. So now P2, for P2 we can say A2 is equal to 4 pi. Now radius is halved, so it becomes R by 2. Okay, so 4 by 2 into R by 2 square. And temperature becomes how much? It becomes twice of the initial temperature. So now P2 will be equal to how much? Sigma into 4 pi into R by 2 square into 2T raised to the power of 4. Okay, so we have to find the value of P2. Just do one thing, just divide P2 and P1. So you get P2 by P1 is equal to sigma multiplied by 4 pi R square by, you can say, 4 into, it becomes 16 T raised to power of 4. And in denominator we have sigma 4 pi R square and T raised to power of 4. So you can cancel out the things in this question, in this expression. So this gets cancelled, this gets cancelled. Wait, we can take different color. So this also gets cancelled, this also gets cancelled. So R square also get cancelled. So we can simply say P2 by P1, P2 by P1 is equal to how much? It's equal to 4. P2 by P1 is equal to 4. Okay, this implies P2 is equal to 4 times P1. So what is the value of P1? In the question it is given that P1 is equal to how much? It's 450 watt. So that becomes 4 times 4 into, sorry, 450. Okay, that becomes 1800 watts. So that means the correct answer is C. Now let's move to the next question. Now this question is from thermal conduction. Now you can see in the same year there are two questions from the same chapter. So this question is quite easier. Two rods A and B of different materials are welded together as shown in the figure. Their thermal conductivities are K1 and K2. The thermal conductivity of the composite rod will be. So students, what can you say? What type of combination is that? Parallel or series? It's series. It's parallel or series? Tell me. Series or parallel combination? What type of combination is that? I'm waiting. It's a parallel combination. You can see because they are connected across each other. So the first thing is that you should know the thermal resistance. Thermal resistance. What is the value of thermal resistance? Basically, thermal resistance is given by this formula. Very good, very good. Thermal resistance is given by this formula. It's equal to 1 by K into L by A, where L is the length of conductor, okay, and A is the area of cross section, okay, and K is the thermal conductivity, okay, where K is thermal conductivity, A is thermal conductivity, and L is the length of conductor, and A is the area of cross section. Okay. And you know that for parallel combination, the equivalent resistance is calculated by this formula. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 and so on. Okay, for parallel combination. And for series combination, R equivalent is given as simply just the addition of all the resistances, R1 plus R2 and so on. So in this situation, the rods are connected in parallel combination. So firstly, what we'll do, we'll find the thermal resistance of each of the rods. So for rod 1, for rod A, we can say R1 is equal to what? R1 is equal to, and let's say L is the length. So 1 by K1, 1 by K1 into L by A. Similarly, for a second rod, R2 is equal to 1 by K2 into L by A, because both of them are having same length and same area of cross section. So the next thing is we have to find the equivalent resistance. So 1 by R equivalent is equal to 1 by R1. What is the 1 by R1? 1 by R1 means K1A by L, and 1 by R2 means K2A by L. So as we have found the value of this R1 and R2, we can also find the R equivalent. So for R equivalent, we have, this complete system of the two rods. Okay. So for two rods, what is the area of cross section? Area of cross section becomes doubled, but the length is same. Okay, but the length is same. So R equivalent is equal to 1 by K equivalent. Let's say K equivalent is the equivalent thermal conductivity, and L by 2A. Okay. So we can, when we substitute this R equivalent in this equation here, we get K 2 times K equivalent into area into A divided by L is equal to K1A by L plus K2A by L. This implies K equivalent is equal to K1 plus K2 by 2. Yeah. So students, in general, you can remember one formula. If there are n parallel rods that are connected in parallel combination, okay, if there are n parallel rods connected in parallel combination, so we can simply write the equivalent thermal conductivity if all of them are having same area of cross section and same length, K1, K2, K3, K4. So we can simply, and up to Kn, so we can say K1 plus K2 plus K3 up to Kn divided by n is the equivalent thermal conductivity for a system of n rods connected in parallel. Okay. So now let's move forward. Now this question is from thermal expansion. So coefficients of linear expansion of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2 respectively. If L2 minus L1 is maintained same at all temperatures, which one of the following relation holds good? So in this question, it is given that there are two rods. There are two rods. One is made of brass and one is made of steel. So alpha 1 is the coefficient of thermal expansion for brass rod, and the length of brass rod is L1. So you know the relation that upon expansion, final length is given by L1 dash equal to L1 into 1 plus alpha delta T, where delta T is the change in temperature. Okay, L1 dash is the final length after expansion. Final length of the rod after expansion. Next thing, L1 dash. Now similarly, we can say L2 dash is equal to L2 multiplied by 1 plus, now oh, wait a while, we actually missed one thing. Alpha 1 was also there. So alpha 1 into delta T. Okay. So, and this one is alpha 2 into delta T. Okay. This is the length, the final length of the rod after expansion when you increase the temperature by delta T. And L2 dash is the length of the other rod, that means the steel rod after expansion when we increase the temperature by delta T. Now, what is given in the question? And the question is given that if L2 minus L1 is maintained same at all temperatures, which one of the following relation holds good? So at particular temperature, if you just find the difference of the two lengths, it remains constant. It remains same. Okay, it remains same. So just do one thing, just find the difference of the two lengths. Just subtract the equation 1 from equation number 2. So what do you get? Simply get L2 dash minus L1 dash is equal to L2 into 1 plus alpha delta T minus L1 into 1 plus, sorry, alpha 1, sorry, it was alpha 2. So this one is alpha 1 delta T. You subtract them, you simply get the value L2 dash minus L1 dash is equal to L2 minus L1 plus delta T can be taken common. So alpha 2 minus alpha 1. Okay. So after that, we can say, now in the question it is given that the length, the difference of the length remains same. The difference of length remains same. Okay. So that means L2 dash minus L1 dash must be equal to L2 minus L1. Okay. I think we have missed something here. Wait a while. In the above expression, it should be like, wait, it should be like this. It should be delta T, if you take common, you get alpha 2 L2 minus alpha 1 L1. Now, and the question is given that the length remains, the difference of length remains same. Although length changes, but the difference between them remains same at all of them. So L2 dash minus L1 dash must be equal to L2 minus L1. So if this is true, that means this thing that I'm pointing right now, this thing will become 0. It has to become 0. If this doesn't become 0, the length, the difference between the lengths will not be constant. So from here I can say that alpha 2, now delta T is not 0. Delta T is not 0. So we can say alpha 2 L2 minus alpha 1 L1 is equal to 0. So from here I can write that alpha 2 L2 is equal to alpha 1 L1. This is the final answer that we are getting. So the correct answer is A. Let's move to the next question. The value of coefficient of volume expansion of glycerine is 5 into 10 raised to minus 4 per Kelvin. The fractional change in density of glycerine for a rise of 40 degrees Celsius in its temperature is. So in this question, we are given with gamma, the coefficient of volume expansion. Gamma is equal to 5 into 10 raised to power of minus 4 per Kelvin. Okay. So we know that V final is equal to V initial into 1 plus gamma delta T. This is the formula for volume expansion. The final volume is given as Vi into 1 plus gamma delta T, where Vf is the final volume and Vi is the initial volume, and gamma is the coefficient of volume expansion. Okay. So we have to find the fractional change in density of glycerine. Okay. So how to find the fractional change? Okay, how to find a fractional change? So see, what is density? Density means mass upon volume. So let's say initial density is rho I, so it's m by Vi, and final density is m by Vf. So we can write it as m by Vi into 1 plus gamma delta T. So from here we can write that rho F is equal to rho I by 1 plus gamma delta T. 1 plus gamma delta T. Because m by Vi is actually equal to rho I. Okay. So this is the relation between rho F and rho I. So we have to find the fractional change. Okay. Rho F minus rho I divided by rho I, we have to find. Fractional change means the difference divided by actual one, initial one. So this is rho F. So we can write rho F is equal to rho I into 1 plus gamma delta T raised to the power of minus 1. So actually the thing is that the value of gamma delta T is very small. Okay, when it's very small, so you must have learned in binomial expansion that 1 plus x raised to the power of n can be written as 1 plus nx for x to be very small. Similarly, we can say rho f is equal to rho I multiplied by 1 minus gamma into delta T. So what we have to find in this question, we have to find the rho I minus rho F divided by rho I we have to find. Okay. So if you just put the values, okay, we just put the values here, rho I minus rho I into 1 minus gamma delta T divided by rho I, you'll get it to be equal to gamma into delta T. So gamma is given to be equal to, gamma is 500 10 to the power minus 4 per Kelvin. This is the value of gamma. And change in temperature is 40 degrees Celsius. Just multiply them. Okay. When you multiply them, you get 5 into 10 raised to the power minus 4. And it's 40 into 40. Okay. So by this, you can say 0.020 is the correct answer. One may think, sir, this gamma is in per Kelvin and temperature changes in degrees Celsius. You should know that change in temperature, whether it's degrees Celsius, whether it's Kelvin, it will be same actually. There's no difference. Okay, change in temperature. I'm talking about change in temperature. So C is the correct answer. So student, thank you so much for attending the session. For more information about NEET Bytes, you can just see this link that's given in the description. And one more information that I would like to give you is about AITS. Okay, and the JEE Power Prep 2019. So you can see that now we have AITS All India Test Series. Okay, so there are 8 part tests and 15 full tests, and all of them are computer based. So as you all know that we have online exams this year. So you can just check this information in the given link. Okay, so let's now finish the session. So thank you so much, everyone. Good night.